The easy way. In this lesson, we're actually solving questions on number operations. And I would say the topic is number operations and powers of natural numbers. We'll be solving 50 questions on this topic, and by the end of this lesson, you should be able to achieve all these objectives. You can pause and then look at them to know your expectations and then how we can work towards it. Now, since this is solely for solving questions, I'll try my best to help you understand. But if along the way you think you need detailed tutorial and an in-depth analysis or explanation of what we are doing in here, then I've got you covered as well. So with that, all you need to do is to log on to the YouTube channel, and then on the channel, you click on Home. So on Home, you come down to where we have, so on the first section, we have popular videos. We have videos that is in order of how I've posted them. Then you have courses, but then you come straight down to numbers. Then on numbers, you look for number operation. It might not be the first one, so you just click so that it brings out more. This is what we want to work on. So on number operations, if you click on it, we have 11 lessons that explains into details all that we are coming to solve in here. So without much ado, let's quickly look into it. So we want to start with question number 1. Now, as we have done so far, I would advise that you take your notebook and then your pen or pencil and then solve along. With each and every question, you pause and try your best to get to the answer, and then you unpause to look at the procedure with which I solve it. After every 10 questions, we get a 30 or 1 minute break. Without much ado, let's quickly start our solutions. Our first question here says, using the doubling and halving strategy, which expression is equivalent to 28 times 5? So we have 14 times 5, we have 56 times 2.5, and then 28 times 10, and then 14 times 10. We know for the doubling and halving, all that it says is, whilst you are halving one of the digits, you are doubling the other. And most of the times we have the digit that is a multiple of 2. So with what we have here, we can easily halve this. You see, so we can halve this, and the half of 28 gives us a 14. So we have what? A 14, and then times. So as we have halved this, then we need to double this. So the double of 5 gives us a 10. We can still have. So we can still have this to give us what? A 7. And then the double of 10 gives us a 20. So it is from here that you can also apply other strategies, such as 7 times 2, giving us what? A 14. Then we just add a 0 to it. Among all these that we've done, which do we see present over here? And that is the D. So 14 times 10. You see, so we have halved 28 and then doubled 5. As simple as that. Let's look at our next question. Our next question says, what is the result of 105.25 times 1 over 100? So this question is actually testing how good you are with division by 100. Why do I say division by 100? You know, we can rewrite this as all over 1. And if it's all over 1, then it's the numerator times the numerator, which is 105.25 times 1. That gives us a 105.25. Then we have a 1 over 100, which also gives us what? 100. So indirectly, we are actually solving 105.25, then divided by what? 100. So when it comes to division by 100, we know the rule. It says, locate the decimal point and move it to the left-hand side. The number of zeros you have here. So with division by 100, we have 1, 2. There are 2 zeros. So what we are going to do is we are going to move this decimal point twice to the left. So that we have 1 and then 2. So it moves all the way from between 5 and then 2 and then comes in between 1 and 0. And that, when written, gives us what? 1.0525. So the rule is simple. Anytime you are dividing by a multiple of 10, just move the decimal point to the left. And if you are rather multiplying, move the decimal point to the right. In that case, our answer is B. Very simple. Let's look at question number 3. Question number 3 says, using the distributive property, how can you calculate 32 times 5? You want to calculate 32 times what? 5. Now, we know how the distributive property works. It says, if we have A, then into bracket B plus C, it is written as what? AB plus AC. Or A into bracket B minus C also gives us what? AB minus AC. Any of this works depending on the number you want to work with. Now, you should note that even though this is the distributive property, we know commutativity. You see, so when it comes to multiplication, the order doesn't really matter because we'll get the same answer. So this here can be rewritten. This first one can also be rewritten as B plus C then times A, which give us a B times A and then C times A, and that is B A then plus C A. The same way, this second one can also be rewritten so that we would have a B minus C multiplying what? Our A. And then A multiplies this, and then we have this. So we have BA minus CA. You see? So with what we have here, how do we evaluate it? We have our 32 times 5. We can rewrite 32 as 30 plus 2. So this is our 32, and then it is being multiplied by 5. Hence, using our distributive property, the 5 multiplies, and then it also multiplies the 2. You see, so the 30 multiplies the 5, and the 2 also multiplies the 5. So that we have a 30 times 5 in one bracket, then plus our 2 times 5 also in another bracket. And that is clearly D. Very simple. Let's look at our next question. Question number 5 says, what is the prime factorization of 60 expressed in indexed form? What is the prime factorization of 60 expressed in index form? So when it comes to prime factorization, we can use either the table method or the tree method. So for this simple one, let's just use the tree, which says if we have our 60, you look for two numbers that are multiples or that are factors of 60, one being a prime. Better still, you can choose to list out your prime numbers. So we have 2, then 3, 5, 7, then the list goes on. So starting with 2, can 2 divide 60? Yes. So if 2 can divide 60, we form two branches. One being what? 2, and the other being 2 times what gives us 60, that is a 30. Now, since 2 is a prime number, we will then circle it because it will form no other branch again. Then we come to 30. We repeat that same procedure with 30. So we come to our list of prime numbers. Can 2 divide 30? Yes. So it divides it 15 times. And this 2 once again is a prime number, so we circle it because it forms no other branch. We continue with what? 15. Does 2 divide 15? No. So the tenor of 2 is done. We are no more going to use 2 again. We come to 3. 3 times what gives us 15? 3 times a 5. Now, you note that 3 itself is a prime number and 5 is also a prime number. So there's no other branch that is going to form. Hence, writing our 60 as product of prime, we are going to get a 2 times the 3 and then multiplying the 5. If you want to rewrite this in index notations, then we say how many times are we multiplying to? Just twice. That is a 2 raised to the power 2 times, we have just a 3 and then times a 5. And that is going to be the prime factorization of the number 60. So where do we see that? That is the A we have over here. Hence our answer is A. I do hope you got the answer on your own. Let's look at question number 5. So the next question says find the highest common factor of 36 and then 72. Since we want the highest common factor, we can use any of the two methods of prime factorization. That is either the tree method or the table. But the table seems to be very, very fast. So let's try that. We have our 32, we have our 36, and then the 72. So what we seek to do is we consider our prime numbers. Our prime numbers we know are what? A 2, 3, 5, 7, then the list goes on and on. So what we want to do is, if it is the factor that you want, that is the highest common factor, you ask yourself, does 2, which is our smallest prime number in this case, does it divide both? So for the highest common factor, you only take the prime number that divides both numbers. So 2 divides 36 and it also divides 72. So we start with our 2. So I'll write my 2 here, and 2 divides 36 how many times? That is an 18. And 2 divides 72 how many times? That is also a 36. Then we continue the same process again. Among these prime numbers, which of them divides both of these numbers we have here? It's still 2. So we start with our 2, and 2 divides 18 how many times? We have 9 times. And it divides 36 how many times? This time around 18. We come again. 2 does not divide 9, so we cease to use 2. Then we come to 3. 3 divides 9 and also divides 18. So we have our 3 here, and 3 divides 9 3 times. And then it divides 18 how many times? We have a 6. We can still use 3 again. So 3 divides 3 just once, and also divides 36 twice. At this point, we only consider these prime numbers. You see, there is no prime number that divides both 1 and then 2. Hence, we are going to end our division right here. So it simply means that our highest common factor, which is our HCF, it is going to be what? The 2 times the 2 times 3 times 3. 2 times 2 gives us what? 4. Then 3 times 3 gives us a 9. If we multiply 4 by 9, we get a 36. So our answer is 36. Now, I had to go through this so that you get to understand this method. But you could have even just looked at the options and even tell the answer. Question number 6. It says, what is the least common multiple of 4 and then 6? If you want our least common multiple, there's one simple method we even use from elementary school. If you have your 4, all you need to do is to list out the multiples of 4. You have 4, you have 8, you have 12, you have 16, You have 20, 24, and then it goes on and on and on. Then we come to 6. So for 6, we have our 6, and then 12, 18, and come to 24, and come to 30, and then it also goes on and on and on. Now we can choose to go on and on, but the question has asked us for the least. So we could have even ended right here. That is the 12 and then the 12. That is the common. So if we actually want the common multiples, then we have 12, 24, 12, 24. And it could have also gone on. But we want the least. So among 12 and 24, our 12 becomes what? The least. And that is D. There is also a way we could use the table method. For this simple example, it wouldn't be necessary. But when it comes to bigger numbers, where you wouldn't want to waste time looking for multiples and all that, then the table method is one of the best. This is how that method goes. It says we have 4 and then 6. So what we do is we divide these numbers with our prime numbers till there is no more a number to divide. What do I mean by that? So we start with 2. 2 divides 4 how many times? Twice. And it divides 6 thrice. Unlike what we did previously, that is for the highest common factor, where you would end if there is no number dividing both. That isn't the case for the LCM. For the LCM, you would still continue until you have 1 and then 1 here. So in that case, we can still use 2. 2 divides 2 once, and then it doesn't divide 3, so we keep our 3 just as you have it here. Then this time we can use 3. So 3 does not divide 1. We don't do that division. But then 3 divides 3 once. So you realize that at this stage, we have both numbers ending in 1. So with that, we can say that our LCM is the product of all of these. That is the 2 times the 2 times the 3. 2 times 2 gives us a 4. Then 4 times 3 gives us a 12. This is a very fast method. If you have more numbers, you wouldn't want to actually look for their multiples. As you proceed, you'd see how useful it can be. So our next question we have here says, which of the following is a prime number? Now, I do hope this one is very, very easy. But my question for you is, what is a prime number? And then, if a number is not a prime number, what is it called? They have names, okay? Such as 4. 4 is not a prime number, but then it is a particular number. So what is that name? Let me know in the comment section. So which of the following is a prime number? It is obviously what? 13. Let's proceed. Now, if you multiply 0.75 by 1,000, how many places does the decimal shift? Remember, in one of our first questions, he said if you have 0.75, you are multiplying it by 1,000. So I said you move the decimal depending on the number of zeros you have over here. If it is division, we move to the left. If it is multiplication, we move to the what? Right. This case here is multiplication, so we are moving to the right. We are moving to the right how many times? 1, 2, 3, because there are 3 zeros. So 3 times. Hence, if we do the multiplication, what becomes of our answer? So we have 1, then our 2. Since there's no number here, we can introduce a 0, then move thrice. So with that, we are going to get a 750 with a decimal point here, which is 750. You see, our next question says, when finding the LCM using the prime factorization, you showed what do we do when you're actually looking for the LCM? using the prime factorization. So with that, I'll take this example here just to explain it. When you want the highest common factor for this number and this number, the highest common factor, what we do is we take all the prime numbers that occurred. So 2 occurred, 3 occurred, and then 5 also occurred. So if you want our highest common factor among the 2's, we are going to take the one with the lowest power. So in this case, we'll be taking 2. In this case, for the 3, we'll be taking what? 1. And also for the 5, we'll be taking 1. On the other hand, for the lowest common multiple, what we do is we have our 2 times 3 times 5. We are rather going to take the highest. So among these two, this 3 is the highest. So we have our 3. And for the 3 as well, this becomes our highest. So giving us our 2. And then for the 5, the 3 is the highest. So take note of the difference. When it is the highest common factor, we take the lowest of the powers. But when it's the lowest common multiple, we take the highest. And this satisfies us. So multiply only the common prime factors using the lowest power of each. That is A. See, very simple. Question number 10. It says, what is the lowest common multiple of 12 and 15? So for 12, we can rewrite 12 as what? That is using the method of prime factorization. So we have our 12, and 12 is a 2 times 6. Then our 6 is a 2 times what? 3. So we can rewrite our 12 as 2 to the power 2, then times what? 3. Then we come to our 15. 15 is actually a 2. It's actually a 3 times what? 5. Just that. So 15 equals 3 times 5. Hence, if you want the LCM, as I said earlier on, we are going to multiply all the prime numbers. So 2 occurred, 3 occurred, and then 5 also occurred. But the powers are going to be the highest among all of them. So for this, there is no 2 occurring. Hence, the only 2 that we have here is that with the power 2 over here. So you put our 2. Then for the 3, they are all having the same powers. So we have our 1 here. And then for the 5, this is the only one that also occurred. So we have 1 over here. Evaluating, we have our 4 times 3 times 5. And 4 times 3 times 5 gives us what? A 60. So it simply means the LCM of 12 and then 15 is what? 60. As simple as that. That is using the method of prime factorization. And then the prime factorization itself, we use the factor tree method. You could have also used the table method. Let me know if you use the table method and you actually had the same answer. This is question number 10. And as I said, we would have to rest a little bit. So give yourself some time, then we move to question number 11. So let's move to question number 11. Welcome back. If you actually took the break, that would be worth it. So it says which combination of mental strategy correctly solves 48. So we have 48 times a 25. Now looking at this just by guessing, you can even say doubling, halving and doubling will work, because the 48 here can easily be repeatedly halved. And then the 25 can also be what? Doubled easily. If we have 48, we are going to get a 24. Then the double of 25 gives us what? A 50. If we have 24, we are going to get a 12. And the double of 50 gives us what? 100. If we have 12, we are going to get a 6. And the double of 100 gives us a 200. If we have 6, we are going to get a 3. And the double of 200 gives us a 400. It is at this stage that we just multiply 12 by 4 by 3, giving us a 12. And then with these annexing zeros, we write them attached to it. So it is obvious halving and doubling is the best method we can use. C here says we have 48 twice to get 12 and double 25 twice to get 100. So for this example they have, it actually ends over here, because multiplying 12 by 100 is worth it. You can just do it very simple. So 12 times 1 gives us the 12, and then we have the 0, 0. So let's choose C and then C. Yes, that is right. You could have as well gone through all these options to weigh them and then get your correct answer. Question number 12. It says if the prime factorization of a number, so our number A is given as what? 2 to the power 3, then times 2 to the power times 3 to the power 2. And then our number B is also 2 to the power 2 times 3 to the power 3. What is their highest common factor? Remember, I said for the highest common factor, which one do we pick? We pick the lowest of the powers. So the highest common factor of A and then B, we pick 2 times 3, all right. Then we now look for the lowest among these powers. So for 3 here and then 2 here, the lowest is what? 2. We are just going to put our 2 over here. Then for 2 and also 3, the lowest is what? 2. Hence, this is all we need. So our highest common factor is going to be a 4, then times a 9, which gives us a 36. But all we need is here. And that is B, 2 to the power 2 times 3 to the power 2. The clue is, if you are looking for highest common factor, we said after multiplying all the numbers that did appear, you take the lowest powers of each and every one of them. But for the LCM, you actually take the highest power. Question number 13. 13 says we have to calculate the result of 4.45.8 then divided by what? 1 over 1,000. You see, now we know that when we want to multiply a number, or let me say when we want to divide a number by a fraction, we use the KCF method. So we keep the first, which we have over here, then we change the division to multiplication, and then we flip this so that it becomes 1,000 over 1. 1,000 over 1 still remains what? 1,000. Hence we have a 45.8 times 1,000. Now if you are multiplying by these multiples of things, all you need to do is to move your decimal point the number of zeros you have over here. So we have 45.8. Knowing our expected answer, you can bring these zeros as placeholders. They don't change the value since you still have your decimal point here. So we are going to move our decimal point thrice. We have once, twice, then thrice. So we don't have it here. Hence we are going to have the 45 with the 8, and then how many zeros attached to it? 1, 2. You see, and that is going to be what? C. So question number 13, let's choose C, and I do hope you got that. Question number 14. It says, which of the following is the correct application of the distributive property to 19 times 7? So we said for the distributive property, there are two ways. Remember, I did one that used addition and the other that can also use subtraction as well. So in this case, let's try out the two and then we now compare it to the answers. So for 19 times 7, if we actually want to use the addition, take note, 19 can be written as a 10 plus 9, and it can also be written as a 20 minus 1. You see, so let's try any of these, or let's try both. Hence, for 19 times 7, using the first one, we can have a 10 plus 9 and then times 7. You see, so let me just bring the time. So times 7. Applying the distributive property, we have our 10 times 7 and then our 9 times 7. It gives us 10 times 7 then plus 9 times 7. This is if you want to use the addition. But if you actually want to write our 19 times 7 as a 20 minus 1, then times your 7. 20 multiplies 7, so that's negative 1 as well. So you have your 20, then times 7 in one bracket, then minus into bracket 1 times 7. Easy. So any of these works. Let's see our options we have over here. So A says 20 times 7, then minus 1 times 7. Yes, that is true. B cannot be the answer because it is 10 times 7. That is totally wrong. C is also totally wrong. Then D as well. Question number 15. What is the LCM of 8, 12, and then 20? 8, 12, and 20. Once again, you can use the method of prime factorization and then also use the table method. I'll use the table method first, then we'll now come to the method of prime factorization so we see the difference between the two. You master the one that you want. So we have our 8, a 12, and then the 20. And all we want to do is to divide. So this is the table method. You can bring these lines as well, that's fine. So using our prime numbers, we'll start with what? 2. Because 2 can divide at least one of them. So we have 2 dividing what? 8. 2 divides 8 to give us 4, and it divides 12 to give us a 6. It divides 20 to give us a 10. We can still use 2. 2 divides 4 to give us a 2. It divides 6 to give us a 3, and then divides 10 to give us a 5. We can still use 2. Now, take note. If we actually wanted the highest common factor, since there is no other number that can divide all of this, we end and then just multiply these. That is 2 times 2. And that becomes the highest common factor. But if it is LCM, you continue till you have 1, 1, and then 1. So since there is at least one number here that 2 can divide, we still continue with our 2. 2 divides 2 to give us 1. It does not divide 3. Neither does it divide 5. Then we come to 3 because at least there's a number 3 can divide. So 1 remains as it is, and then 3 divides 3 to give us what? 1. 5 also remains as it is. The only prime number here that we can divide is 5. So 1 remains as it is. Then 5 divides 5 to give us 1. So at this stage, we have what? 1 ending all the what? Columns. So our LCM is going to be, so the LCM of 8, 12, and then 20. It's going to be the product of all these numbers we have here. That is a 2 times 2 times 2, then times your 3 times 5. Multiplying all of this, we have 2 times 2 giving us a 4, 4 times 2 giving us an 8. 8 times 5 gives us a 40. Then the 40 times 3, we have our 120. So our answer is what? A. That is if you wanted to use the table method. But then if you don't want to use the table method and you actually want to prime factorize, starting with 8, you can rewrite 8 as 2 times 4 and 4 as 2 times what? 2. Hence our 8 becomes 2 to the power 3, you see. Then for 12, we rewrite 12 as 2 times 6. 6 as 2 times 3. And we now have our 12 as 2 to the power 2, then times 3. Then we come to 20. 20 is rewritten as 2 times what? 10. 10 is a 2 times 5, all prime. Hence our 20 is what? 2 to the power 2, then times 5. So if it is the LCM of 8 and 12 and then 20 that we want, looking at our prime numbers we have, starting with 2. So 2 to the power, what is the highest power? This has a power of 3, this has a power of 2, this has a power of 2. Hence we are going to take the power of 3 because we said we always take the highest. So 2 to the power 3, then times, we come to what? 3. Over here, 3 is to the power 0. I hope you know that. And 3 is to the power 0 as well over here. 3 is to the power 0 is still 1. So we have 0, 1, and then 0. 1 is the highest in this case. So we pick the 1. Then we have times 5. The 5 here is to the power 0 as well. That here is also to the power 0, but then we have just 1 here. So we pick this. And then you do your simple evaluation. 2 raised to the power 3 gives us an 8. Then times a 3 times a 5, which in turn gives us a 120. Any of them works, just as I said. So you stick to the one that you have mastered. Question number 16. Which set of numbers contains only prime factors of 120? Only the prime factors of 120. We can easily do this by determining what the prime factors of 210. So for 210, starting with 2, we have 2 times 105. So 105. Now, can we divide with 2 again? No. So we move to the next prime number. How do we know we can divide with 2? A number is divisible by 2 if it ends in what? An even number or 0. But for 3, a number is divisible by 3 if the sum of the digits is divisible by what? 3. So we have 1 plus 0 plus 5, which gives us 6. And 6 is divisible by 3. Hence, 105 is divisible by 3. So we have our 3. So 3 divides 105. That is a 35 times. Then we continue with our 35 since it's not prime. For 35, we can use the 5. So 5 divides 35 to give us what? A 7. Now with this, there's no other number to form a branch. So picking out our prime numbers, we have our 2, 3, 5, and then 7. So the set of prime factors of 210 then becomes a 2, a 3, 5, and then what? 7. So let's go to our options and see which one satisfies. So we have 2, 3, 5, and 7. That is A. And then that is just it. Question number 17. It says we want the highest common factor of 45, 75, and then 105. This is the best example of the reason why you need to use what? The table method. So we have our 45, then the 75, and then 105. So for highest common factor, using the table method, we only look for the number that divides all of them. If we don't get any number that divides, or specifically a prime number, you see, so if you don't get a prime number that divides all of them, you cease and then multiply or find the product of the prime numbers you have accumulated. Starting with 5, we know all these numbers end with 5, so it means 5 can divide all of them. So 5 divides 45 to give us what? A 9. And it divides 75 to give us a 15. So we have 15. So for our last digit, 5 divides 105 to give us a 21. So our new set of numbers are 9, 15, and then what? 21. Now we want to use a number that divides all of them, specifically a prime number. And the best prime number is 3. So 3 divides 9 thrice, and it divides 15 5 times. It divides 21 7 times. We end over here because we have 7, 5, and then 3. These numbers you have here are co-prime. They don't even have any common factor, to talk of common prime factor. So we end right here, and then our highest common factor is the 5 times 3. And 5 times 3 gives us a 15. So our answer is B. The beauty of the table method is that whilst you solve for the highest common factor, you can actually proceed to get your LCM as well. Because if we are to proceed here, then we would have continued with what? 3. And 3 gives us 1 here. Then we still have our 5 and then 7 right here. With 5, we still have the 1. Then 5 into 5 giving us a 1. Then 5 into 7, we don't work that. And then you now come to your 7. You see, so multiplying all these numbers here would have given us our LCM. We kill 2 stones. We're actually killing 2 birds with 1 stone. Question number 18. If you multiply a decimal by 10 to the power 3, which statement is true? Remember, 10 to the power 3 is simply 1,000. You see, so how many zeros has 1,000? 3. Sometimes you can just use the power you have over here. If you are multiplying a decimal by 10 to the power 3, it simply means you are moving the decimal point 3 times to the right. Let's look at the options we have. It says it is the same as multiplying by 1,000. That is shifting the decimal 3 places to the right, just as I said. That is true. It is the same as multiplying by 30. That is false. 10 to the power 3 is not 30. I repeat, 10 to the power 3 is not 10 times 3, but it is rather 10 multiplying itself 3 times. You see, so 10 to the power 3 is actually a 10 times 10, then times a 10, which gives us 1,000. Then C says the decimal shifts 3 places right only if the number is an integer. That is false. Then it is the same as divide. No, it says multiply, so we don't even consider that at all. Question number 19. It says if the factor tree, in the factor tree of 420, if the first branch is 12, so we have 12, that is, let me clean this. If our first branch is 12, that is, you started with 120 and then your first branch was 12, that is fine. So for 12, you would have a 10 over here, just as the question has said. When you want to actually work your prime factorization and you start with 2 composite numbers, unlike the one I have done since the beginning of this lesson till now, you are going to form branches on both sides. You see, not only on one side. It says, what is the final prime factor? 12 You know, the branches are formed on composite numbers. That is, numbers that are not prime. But if a number is prime, it doesn't branch anymore because it has no other factor except itself and 1. So for 12, we are going to get a 2 times 6. So we have 2 times 6. And then for 10, we are actually going to get a 5 times what? 2. That ends right here. But this, on the other hand, has 2, which is prime, and then 12, which is a composite number. So it is also going to continue forming branches. 6 gives us a 2 times 3, and they are both prime. So our 120 becomes the product of all the circled ones, which is a 2 times 2 times 3 times 5, and then times 2. If you actually want to arrange them, we have 2 times 2, then this 2 here. So times 2, then times 3, times 5. As index notation, you have 2 to the power 1, 2, 3. So 2 to the power 3, then times 3 times 5. Now let's go to our answers. We have 2 times 3 times 4 times 5. That is not what we have here. We have 12 times 10. If you want to write a number as product of prime factors, all the numbers should be prime. 12 is not prime, neither is 10. We have 2 times 2 times 2 times 3 times 5. That is exactly what we had here. So we choose C. Question number 20. It says, which calculation shows the results of what? 40 plus 8. And then it says times 5. So we are using the distributive property. The distributive property simply means we should multiply this by this and also multiply this by this. So we have 40 times 5, which gives us what? The 40 times 5. Then into bracket, 8 times 5. 40 times 5 gives us a 200. Then we have 8 times 5, which also gives us a 40. If we are to add these two, we have what? 240. That is A. Very simple. That was question number 20, and we will be pausing here. Kindly stand and stretch so that you be recharged, then come so that we proceed with the remaining questions. Welcome back from that break. Now let's proceed with question number 21. And it says, which of the following mental strategies is most efficient for calculating a 1400 divided by what? 25. 1400 divided by 25. So with this, we would have to look at the possible answers. The first one says we should have 1400 to 700, and then we should have 1400 to 700 and then double 25 to get 50. So are we actually trying to say this is the same as 700 then divided by 50? No, that is not true. This method is actually the halving and doubling, and it works for multiplication and not for division. So this is out. The second one says we should add 75 to 25 to make 100, and then divide this by what? 100. That is also not going to work. But let's look at the C. It says let's multiply both numbers by 4 to get 5,600 and then 100. So what they are saying is, instead of the 1,400, let's multiply it by 4. And then for the 25 as well, let's multiply it by 4. You see, and by so doing, this here gives us a 5, that is 5,600. Then we get divided by 25 by 4 gives us 100. So this would actually work. This would be the best choice because we can easily divide by what? 100. Initially I said if we want to divide by 100, we move our decimal, the number of zeros you have right here. You see, so let's try C and then C. That is correct. The next question is what is the result of dividing what? 0.0045 by 1 over 100. So we apply our knowledge of fractions over here. We know if we have a number, in this case 0.0045, and we are dividing by a fraction, what do? We change our division sign to multiplication and then flip this so that it becomes 100 over 1. Now we know the over 1 will still maintain the value. Hence, let's just say we have 0.0045 multiplying 100. So since we are multiplying by 100, all we need to do now is to move the decimal place 2 times to the right. So we have 1 and then 2. You see, so the new position of the decimal place is between this 0 and then this 4. And that is going to give us a 0.45. So among our answers, we have what? The C. So that is it for question number 22. Number 23 says, if two numbers have an HCF of 12 and an LCM of 72, if one of the number is 24, what is the other number? This is a very interesting question. Let me use this opportunity to then teach you one formula you wouldn't find in most books. So if you have a number A and then you have another number B. Now, if you have to find the LCM of this, so the LCM of A and then B, and you also multiply it by the highest common factor of A and then B, you actually get an answer which is equal to the product of the two numbers. You see, let's actually take some examples so you see what I'm talking about. So if we have 6 and then 4, now we know the LCM of 6 and then 4 is what? A 12. We also know the highest common factor of 6 and then 4 is 2. What is the product of 6 and then 4? It is a 24. Now looking at our LCM and then HCF, if you have to multiply the LCM of 6 and then 4 by the highest common factor of 6 and 4, what do we get? We get a 2 times 12. And 2 times 12 gives us what? A 24. This is the idea we are going to employ to solve this question over here. So the idea once again is, if you multiply the LCM by the highest common factor, you would actually get the product of the two numbers. Let me erase this side so we work here. So with that, it says two numbers have HCF of what? 12. So we have the HCF of the two numbers being 12. And then their LCM being what? 72. Now, one of the number is actually what? 24. So let's say our numbers are 24. And let's let the other one be a variable. So let's say a y. Now, using this formula I have stated here, the highest common factor times the lowest common multiple will be equal to what? 12 times what? Your 72. You see? So we are saying the 12 times the 72, which is the product of the highest common factor and the lowest common multiple, is going to be equal to 24 times y. So at this point, it's all about making y the subject. So how do we make y the subject? We divide both sides by our 24. So with that, this 24 easily cancels out this 24 and have 12 into itself once, into 24 how many times? Twice. You see? Then with that, 2 divides itself once, then it divides 72, 36. So that simply means y, that is the other number, is what? 36. I would advise you really go over this particular solution because this is a very new concept, which says the LCM of a number and the product, the LCM and then the HCF, that is their product, is equal to the product of the two numbers, and we are getting what? 36. So that is A. You see? Okay. So let's look at question number 24. Question number 24 says, find the prime factorization of 180 in index form. As we have done so far, you can either use your table method or the tree. So we have 180, and then what two factors of 180 do you know? We can get a 10 and then an 18 as well. For these two, they are all not what? Prime. They are all composite numbers. So for 10, we are going to have a 2 times a 5. For 18, on the other hand, we have a 2 times a 9. This 2 here is a prime. This 5 is also a prime. This 2 is also a prime. But 9 remains a composite. And composite numbers are always branched. So 9 then gives us a 3 times what? 3. So with that, our 180 can then be rewritten as a 2 times 2 times 3 times 3, then times 5. I have chosen to write them in what order? So choosing to write them in index form, we have 2 to the power 2, then times 3 to the power what? 2, then times 5. You see, so these prime numbers you see here were just those that we circled right here. Okay, so this is 180 written in index notation, and that is A. Now let's proceed. Question number 25. Question number 25 says, which set of prime factors belong to the number that is a multiple of both 6 and then 10? Which set of prime factors belongs to a number that is both a multiple of what? 6 and then 10. So all this question is asking us is that for 6, let's rewrite 6 as product of prime, or look for the prime factors of 6. Now the prime factors of 6 are simply what? Or you can say 6 is simply 2 times your 3. Then we come to 10. 10 is also a 2 times what? 5. They said, which set of prime factors belongs to the number that is a multiple of both 6 and then 10? Now, if we actually wanted numbers that are multiples of both 6 and 10, we would have 30. And if we have 30, we can rewrite 30 as 2, then times a 3, times a 5. If we had 60, 60 would then be written as a 2, times a 2, times what? 3, and then 5. Do you see any pattern? If you had a 120, it would have also been a 2, then times, 120 is 2 times 60. So 2 times, then all these we wrote for 60, which is your 2 times 2 times 3 times 5. You see? So if you wanted the unique set of numbers that are occurring over here, it is just a 2, a 3, and then a 5. They are the same numbers that are repeating all over. You see? So our set is going to be what? 2, 3, 5. As simple as that. Question number 26. Number 26 says we have to apply the distributive property to find the value of a 15 then times a 102. You see? So applying our distributive property, what do we know? We have a 15 then times, so instead of the 100, we can write, instead of the 102, we can write 100 plus 0 and then plus 2. You see, now we know the 0 yields nothing, so it can still be written as 15 times what? 100 plus 2. 15 times 100 gives us a 15, then we put the 2 zeros attached. 15 times 2 also gives us what? 30. If you have to add these two together, we have 1530, and that is what A. So you see, this distributive property is a very quick and then easy way to actually solve some of these multiplication problems. Our next question says, what is the highest common factor? So we have 2 to the power 3 times 3, then times 5 squared. And we also have 2 to the power 2 times 3 to the power 2 times 7. So if you want our highest common factor, we know we pick among these the lowest powers. So we have 2 occurring, we also have 3 occurring, we also have 5 occurring, and then we also have what? 7 occurring. This is what I advise my students to do. So you actually write all of them. It's a very quick way. So relax and then see. So we have our 2, among 2 and then 3, which is the lowest power. So we have what? 2. Then we come to the 3's. This is to the power 1, and then this is to the power 2. So the lowest power is what? 1. Among the 5, this particular one has got a power of what? 2. But there is none over here, so it's actually a power of 0. You see, so there is 0 over here, hence the lowest is what? 0. If we come to 7, 7 has got a power of 1 here, and then this has also got a power of what? 0. And among these two, the lowest is what? 0. You see, now the reason why we don't write all these is that they'll give you 1. So at the end of the day, you just have a 2 to the power 2, then times a 3. You know, this all becomes times 1 times 1. So 2 to the power 2, we know, gives us a 4. Then we multiply it by 3, which then gives us a 12. So you can see the highest common factor is 12. As simple as that. Our next question says, how many prime numbers exist between 20 and 30? How many prime numbers exist between what? 20 and 30? So one easy way to get this is to write all the odd numbers between 20 and 30. So between 20 and 30, we have 21, then we have 23, we also have 25, and then we have 27, and finally 29. Then you now cancel out those that you think have factors. We know at least 21 has a factor of 3, and then 7 as well. And then we can't think of anything here, but for 25, a number is divisible by 5 if it ends in what 5. So 5 can divide 25. When it comes to 27, we can also say a number is divisible by 3 if the sum of the digits is divisible by 3. So 2 plus 7 gives us 9, and hence it is divisible by 3. Now these two, there are no significant, or there are no numbers that can divide them. So we can settle on these two being what are prime numbers. That is the 23 and then 29. If you knew it off head, you could have as well simply gone right in to choose your answer. So we have what? Just two of them. That is two. So that's fine. I do hope you got it. So question number 29. It says if you wanted to find the LCM of 15, 20, and 30, which number should you start with to check multiples efficiently? Well, so if you actually want to use the method where we would have to list out all the multiples, you see, it is always advisable you start with the biggest one, because with the biggest one you get to get a range of values that you'd always be testing the smaller ones from. For instance, we can write our 30 here and then 60. Then gradually we can start with the smallest one. So we have 20, then we have what? 40, and then 60. And for the 15 as well, we would have our 15, 30, 45, and 60. So starting with the biggest one gave us at least a limit. You see, you could have as well gone to what 90, and that alone is fine. And that would gradually regulate the number of digits of multiples you need to find for the remaining. So as we did initially, we just found 2, and this led us to find what 3 more here and then 4 more here. The biggest one is the answer because you just need to find a few and depend on it to get the remaining. So that is 30. Our last question for this section, so that you take some few minutes of break. It says, what is the LCM of 2 times 3 squared and 2 squared times what? 3. So for LCM, on the other hand, just as we did for the highest common factor, just multiply all the numbers you have present. And for LCM, you're actually taking the highest of these. So among the two, the highest is what? The highest power is 2. And for the 3, we also have what? A power of 1 here and then 2 over here. So the highest is what? The 2. So simplifying this, 2 to the power 2 is 2 times 2, which gives us what? A 4. Then 3 to the power 3 is 3 times 3, which also gives us a 9. And we know a 4 times 9 gives us a what? 36. So our LCM here is actually what? The 36, which is B. This is question number 30. Let's take some few minutes of break. Then we come and then proceed. Okay, so welcome back. We now want to start from 31 to question number 40. As I've always advised, get your notepad with you, and as you read the questions, you try on your own, get your answer before you on pause, and then check for the right answer. By so doing, you are actually learning and not just following. Mathematics has to do with constant practice. So in as much as you are watching the video, it is a nice thing to do, but it is best you actually solve yourself to gain mastery over what we are doing. Question number 31. It says, if the highest common factor of two numbers, so we have HCF of the two numbers being 6, and then the LCM of the two numbers also being 144, and one of the number, so one of the number is actually what? 18. We have to find the other number. I think we solved an example of this in our previous session, which says if you multiply the LCM, if you multiply our LCM of two numbers by the highest common factor, it is the same as the product of the two numbers. So A times what? B. In this case, our LCM is 144. We are multiplying it by our highest common factor, which is a 6. So if our first number is 18, then let's multiply it by the second number. Let's say the B. So it's all about making B your subject. You see. So what are we going to do? We are just going to divide both sides by the 18 and divide this side also by what? The 18. So with that, we can easily say this 18 cancels out this 18. And 6 divides itself once and then divides 18 how many times? 3 times. What of 144? So for 144, you have 3 dividing itself once, and then it's dividing 144 48 times. Yes, so you can try that. So with that, we would have our 48 being equal to what? B. So B is actually equal to 48. And do we have that here? We have 36, 24, 72, and 48. So that is our answer here, which is D. Question number 32. It says, which of these is the most efficient mental strategy to solve 35 times 18? We want to find 35 times 18. Looking at this, one of the best ways to use the doubling and halving method. So because this here can easily be divided by, let me say, 2. So if we double 35, we are going to get a 70. Then if we have 18, we are getting a 9. You see, then with this, we have just 7 times 9. Do you see? And we know 7 times 9 gives us what? A 63. Then we just add our 0 here nicely. See, so one of the efficient way to do that is by using the doubling and halving. Our first one says we should round 45 to 40 and then 80 to 20, multiply and then we subtract. No, that is not good at all. The next one says we have to divide 35 by 5 and then multiply 18 by 5. That is also not good. As I said, the best one is to use a doubling and then halving. So I think that is D. It says double 35 to get 70 and then half 18 to get what? 9. Then you can easily multiply your 9 by 7 to give you your answer. So the doubling and halving strategy converts the problem into basic multiplication fact involving multiples of what? 10. In this case, it is saying multiples of 10 because our 70 can actually be multiplied by 10 minus 1. 70 times 10 gives us what? A 700. Then 7 times 1 gives us a 70. And then we just subtract, which also gives us the same answer as what we have over here. Question number 33. 33 says, what is the highest common factor of 2 to the power 4 times 3 to the power 2 times 5? And then the next one is 2 to the power 2 times 3 to the power 3 and then times 7. So if you want the highest common factor, all the numbers we have is 2. We have 2 and then 3, 5 and then 7. So as I've said repeatedly, for highest common factor, we go in for the lowest of these powers, you see. And I wrote all for a reason. So let's look at how we are going to work that out. The power of 2 here is 2, and then the power of 2 here is 4. The lowest is what? 2. The power of 3 here is also 2. That of 3 here is also 3. The lowest is what? 2. Then we come to 5. This has not got a 5, so it simply means it has 5 to the power 0. And we have what? 1 here. The lowest is the 0. And for 7, this has not got a 7, so it actually has a power of 0. But then we have 1 here. The lowest among these is what? The 0. So with that, we have 2 to the power 2, then times 3 to the power 2. All these have a power of what? 0. And we know when a number have or has a power of 0, we have 5 to the power 0, which gives us 1, then times 7 to the power 0, which will also give us 1. And this would even yield just 1. So there's no need writing it. Hence, we have 2 to the power 2 times 3 squared, which is C over here. I do hope you were able to get that. Question number 34. 34 says, a merchant wants to pack 48 apples and then 72 oranges into crates so that every crate has the same number of each fruit. What is the maximum number of items per crate? This is a word problem that features the highest common factor. You see, because you are actually dividing, you are dividing something. Division has to do with factors. Anytime you see these word problems, the clue you use to identify whether it's LCM or HCF is, are we trying to reduce something or we are trying to increase something? If you are trying to reduce, then it is actually factor. Hence, we need the common factor. So if we want the common factor, we have a 48 and then the 72. This time around, I would say let's use the table method. So for the table method, I'm going to do my straight line here. This is fine. And then we start with our prime numbers. So the smallest prime number is 2. So using 2, 2 divides 48 to give us what? A 24. You know, for the factors, for the highest common factor, we only divide with the prime numbers that can divide both at a given time. 72 is also divisible by 2, and that gives us a 36. These two numbers are what? They are even, so we can still proceed with 2. 2 divides 24 to give us a 12, then divides a 36 to give us an 18. These numbers are both even, hence 2 can continue, it works. 2 into 12 giving us a 6, and then 2 into 18 giving us a 9. This is where 2 ceases. Now we move to the next prime number, which is 3. So 3 divides 6 to give us a 2, then divides 9 to give us what? A 3. There is no single prime number that can divide both 2 and then 3. Hence, we end over there. Now, our highest common factor becomes the product of these. So, HCF of 48 and then 72 is actually our 2 times 2 times 2 and then times 3. 2 times 2 gives us a 4. 4 times 2 gives us an 8. And then 8 times 3 gives us a 24. So it simply means that the maximum number of items per crate, so that every crate has the same number of each fruit, is actually 24. She needs to pack them in that order. So that is our answer to question number 34. Question number 35, on the other hand, says we have to solve this expression we have over here. This is to test our understanding on what division of multiples of 10. So we have 0.084, then divided by a 1 over 1,000. If this is the case, then we need to apply a principle that says if we are dividing by a fraction, we tend to multiply and then reciprocate what we have as the fraction. In this case, it becomes 1,000 over 1. And since it is over 1, we know it's maintained as what, 1,000. Now, since we are multiplying by 1,000, we are going to move the decimal a number of times. So we have 1, 2, 3. So we are going to move our decimal once, twice, then thrice. The decimal's new position, the decimal point's new position, becomes what we have in front of the 4. So that is 84, which is 84. The answer here is D, and that is right. Okay. So we look at question number 36. We are actually going fast because all these things have been done already, but then it's just an increased difficulty now. Which set of prime factors correctly represents 210? So all they are trying to let us do is to multiply or to rewrite this as product of prime factors. 210 gives us a 21 times what? 10. Whereas our 21 is a 3 times 7, and then our 10 is a 2 times what? 5. And we want to focus only on the prime numbers. You see? So 210 is then rewritten as our 2 times the 3 times the 5, then finally times the 7. You see? So with that, our answer is going to be what? B, which is 2 times 3 times 5 times number 7. Question number 37. You can try that yourself using the table method. So we have our 12, 18, and then 24. And we want the we want the lowest common multiple. If you are using the table method, unlike that of the HCF, you'd keep dividing even if you have no number that divides all of them. So first of all, let's start with the number that divides all of them. And we have 2 because all these numbers are even. 2 divides 12 to give us a 6, 18 to give us a 9, 24 to give us a 12. What number can we continue that divides all of them? So we have 3, which divides 6 to give us a 2. It divides 9 to give us a 3, and then finally divides 12 to give us a 4. Is there any number that can divide all of them? No. So with that, assuming we were to look for the highest common factor, then we'll just end here and say it is 2 times 3. But since it is LCM, we can now proceed with the numbers individually. So we have 2 that can divide 2 to give us 1, and then divide 3. It doesn't divide 3. We don't tolerate decimals here, so we just keep the 3 just as it is. And then 2 divides 4 to give us a 2. We can still proceed with 2. Our aim is to get 1 throughout. You can also say if you achieve only prime numbers here, then you just multiply these numbers by the prime numbers you have here, which will also give you the same answer. But to be on the safer side, let's follow this and then achieve 1 throughout in our last row. So with 2, we know this 1 has already been achieved, so this row is out of the equation. But then 2 does also not divide 3, but then divides this 2 to give us 1. We are finally left to the 3. So this 1 remains, and then 3 into 3 once. Then we have this 1 over here. So these are the numbers whose product will give us the LCM that we seek. So with that, we are going to multiply our 2 by 3 by 2 by 2, and then also by what? 3. 2 times 3 gives us a 6. 6 times 2 gives us a 12. 12 times 2 gives us a 24. And then a 24 times 3 gives us what? A 72. So 32. So our 72 becomes the LCM of what? 12, 18, and then 24. As simple as that. Question number 38. Now, it says 75%. What is 75% of 160? And it actually says you should use benchmark fractions. So if it was objectives, just as we are doing now, you can just solve anyhow and then get your answer and move on. But if it is subjective, it specifically says you should use benchmark fraction. So what it simply means is you rewrite this as a fraction. 75 over 100. We know 25 divides 75 to give us what? 3. And 25 divides 100 to also give us a 4. So it simply means if you want 75% of 160, then it is the same as looking for 3/4 of 160. For 3/4 of 160, what do we see? 4 divides itself once, and it divides 16 4. So into 160, 40. Then we have 40 times 3, which then gives us what? A 120. So our answer is A, right here. We proceed with question number 39. We are gradually getting to the end of this session. Question number 39 says, if x is a prime number, how many factors does x squared have? So we have x being a prime number, and then we actually want the factors of x squared. How do we get it? Let's use some few examples to get this. After getting these from the example, we will establish a rule that will always guide you, so that anytime you see something like this, you don't need to even use examples. If we have 2 is a prime number. Now, the square of 2 is actually what? 4. So, for 4, what are the factors of 4? It is just 1, 2, and then 4. You see, these are the only factors of 4. If we take 3 on the other hand, 3 squared gives us 9. What do you think are the factors of 9? We have 1, we have 3, and then 9 as well. These are the only factors of 9. Our next prime number is what? 5. The square of 5 is 25. What are the known factors of 25? We have 1, we have 5. Is there any that comes before 25? No, it ends there, just 25. So do you see the pattern? Hence, if we have x as a prime number and we have x squared as the square of the prime number, the only factors it ever has is 1, x, and then the number itself. You see, and that gives us what? 3. This has 3 factors, 9 has 3 factors, 25 has also got 3 factors. So generally, x squared is going to get 1, which we see here, the number itself, that squared, to give us the x squared, and then the x squared itself. So a total of 3 factors. Simple as that. Question number 40. Question number 40 says you have to calculate 1,400 by divided by 25 using the scaling mental strategy. So for the scaling mental strategy, all it says is scale this one up. Or if you can scale it down, that is fine. So scaling it up simply means You look for a number that you multiply by these two numbers so that they can get to an easier set of numbers that you can work it even mentally. With that, you realize that if we multiply 25 by 4, we are getting 100. And we all know division by 100 is very, very easy. So why not just multiply these two numbers by 4 and then by 4? You see, so with that, we are going to get 1400 by 4, which gives us 5600. So divided by 25 times 4, on the other hand, gives us what? 100. So with this, we have gotten a number divided by 100. And when it comes to division by 100, it is just about moving our decimal places a number of times. So we have our decimal point here, and since it is by 100, we move it 2 times to the left because we are dividing to give us a 56. And that is what B. As simple as that. It is time for another break. The breaks are really, really necessary to get you relaxed and then less tensed. See you in our next session in about some few minutes so that we can proceed. Welcome back. And in this session, we are looking at our last set of questions. That is from question number 41 to question number 50. I do hope with all that we've done, you are gaining mastery on this substrand, that is number operations and powers of natural numbers. As I said earlier on, if you need in-depth tutorials on this lesson, you can always check on my homepage and then come to the required section as I showed you in the beginning of this video so that you get more understanding. Question number 41, as I've always advised, you should always try the question yourself before you come and then check the answer. In that way, you learn and learn for yourself, not just watching. A rectangular floor measures 120 centimeters by 150 centimeters. So this can be the rectangular floor we are talking about. And then it says it measures 120. So we have 120 centimeters. And then, so I would actually take the 120 and put it here. And then 150 centimeters. So you want to cover it with the largest possible square tiles without cutting any. What should be the side length of each tile? What does this question actually mean? Now, these are two tiles that we have. For this, we can arrange 1, 2, 3, 4, and then 5. You see? And let me just redraw this so that I actually use it for this demonstration. So this rectangle will be good for the demonstration. Now, if I'm to rearrange these tiles here as well, you see, I'll get this and it fits perfectly well. So with that, I can easily arrange the remaining so nicely. And then with that, we have fixed our tiles in the room without having to cut any piece. Okay. Now, with this bigger one on the other hand, if we were to arrange it, I have one here, and then I have another over here. I have another here, and then there is another here as well. You see, so it goes on, and you realize that there will be spaces we will need to cut some tiles to do what? To occupy. So for instance, for these remaining spaces over here, this we'll need to cut smaller pieces of the tile so that it occupies. And then for these remaining spaces over here as well, we need to do the same so that the decoration will be nice. But we don't want that to happen. So we want, as mathematicians, we actually want to calculate what is the biggest tile size that will work. That is what this problem is asking you for. You see, and it is actually what? A highest common factor problem. It is a highest common factor problem. And we want the highest common factor of what? 120 and 150. So what do? We have 120. So this is more of an application question. So we have 120 and we are multiplying it by what? A 100 and no, we have 120 and then we have 150. So if you want the highest common factor, as I've always loved using the table method, which is a little bit faster. So the highest common factor, we start with what? 2, because they are both even. 2 divides 120 to give us a 60, then divides 150 to give us a 75. Now since this is not even, we cannot proceed with what? 75, but then we can proceed with 5. Yes, because 5 can divide both. The number is divisible by 5 if it ends in 0 or 5. So with a 5, what times 5 gives us a 60? We have a 12. And then what number times 5 gives us a 75? That is a 15. We now have 12 and then 15. We can also proceed with what? 3. So 3 divides 12 to give us a 4, and it divides 15 to give us a 5. And with these two, there's no number that can divide both. Hence, our highest common factor of the number 120 and then 150 is what? A 2 times 5 and then times 3. 2 times 5 gives us a 10, and then 10 times 3 gives us a 30. So the tile size should be what? 30 by 30 centimeter. That is the square of the tile we need, just as I illustrated. So we need all those tiles to be what? This. Question number 42. What is the highest common factor? We've done these so many times, and this time around, I'm actually not going to solve. So I think let's just look at it and then determine our highest common factor. We know for highest common factor, we are actually looking for the one that is common, the lowest power. We have 2 here and we have 2. The lowest power is 2 to the power 2. So among these, we have B and then C being our potential answers. 3 to the power 2 and then 3 to the power 3. We want the lowest. So among these, they all have the 3 to the power 2, out of the 5. There is 5 here and then there is 5 here. It is to the power 1 and this is to the power 2. The lowest is what? To the power 1. But we have a 7 here, we don't have a 7 here. So that should tell you that this is actually eliminated. And our right answer is C. Sometimes when it's actually objectives, and then you know the concept of whatever you want to do, there is no need trying to work them all out to prove a point. It rather ends up wasting your time. You need to save time and then actually approach the questions that you think are more difficult. So for question number 48, which we've also done most of, is which of these mental strategies is most efficient for calculating 2,800 divided by 50? And you remember the scale up method. Yeah, we can easily multiply 50 by 2 to give us 100. And if we multiply 50 by 2 to give us 100, and whatever we get here after multiplying this also by 2, we are going to get what? that divided by 100. We know when it comes to division by 100, it is very easy. So this is what I mean. We have 2,800 divided by what? 50. So all we are going to do is to multiply this by 2. So that it becomes a 5,600. Then divided by, you multiply this also by 2, which then gives us what? 100. You see? So our answer is double both numbers to get 5,600 divided by 100. It says find the other number if the HCF and then the LCM of two numbers are 13 and 455 respectively, and one of the numbers is 65. We've done most of these as well. So I said the rule is the highest common factor then times the lowest common multiple is simply the product of the two numbers. In this case, we have the highest common factor being 13 times 455, and it's equal to a 65 times b. Hence, if we want b, the only thing we need to do is to make b the subject. Making b the subject here simply means dividing both sides by what? 65. So that this 65 takes out this 65. Then with that, we can say 13 divides itself once and it divides 65 5 times. 5 divides itself once and then divides 455 how many times? 91. So it simply means we have 91 times 1, which gives us a 91, then all over 1, and that gives us our b. So it simply implies that our b is equal to what? 91, and that is all. So that is D. What is the LCM of 15, 25, and 30? The LCM. We've done most of it as well. So using our table method, we have 15, 25, and 30. Then which prime number divides all of it? We can simply use our 5. 5 divides 15 thrice, and it divides 25 5 times, and it divides 30 6. We can still use our 5, and then 5 doesn't divide 3, but it divides 5 once. It doesn't divide 6. We come to our 3. 3 divides 3 once. Then into 6 twice. Then we now come to our 2. These are already ones. So our LCM is 5 times 5, which gives us 25. Then 25 times 2, which gives us 50. Then 50 times 3, which gives us a 150. So our answer is what? 150. Question number 46. It says, if the number n has a prime factorization of 2 raised to the power 7 times 5 times 7, which of the following is not a factor of n? So how do we solve this? The number n is what? 2 to the power 3, then times 5, and then times 7. So we could have, what we can easily do is, let's write 70 as product of prime factors. 70 becomes, working it out, we have 70, which gives us a 2 times 35. Then 35 gives us a 5, and then times what? 7. So 70 actually becomes a 2 times 5, then times 7. And then if we take 15, so 15 is simply a 3 times 5. 20 is also what? You have a 2 times 5 and then times 2. So 2 raised to the power 2. And then we have 14, which also gives us a 2 times what? 7. Now, if you want any of these numbers to be a factor of n, then its prime factorization should also be a factor of n's prime factorization. If we take 2, we have 2 in here, we have 3, and we have 7. If you take that of 15, it hasn't got a 3. So n has not got a 3. But then for 20, we have 2 raised to the power 2, which is inside this. We have 5, which is also here. And that alone is enough. Then for 14, we have 2, which is also inside this. And then we have 7, which is also inside this. So simply put, you just need to make sure that the numbers prime factorization is a subset of what you have over here. And in this case, we have 15, which doesn't satisfy that. So 15 is not a factor of the n in question. Question number 46. It says calculate 12.5% of 800 using our benchmark fractions. So if you have 12.5%, it is simply 12.5%. Means over 100. You see, and for 12.5 itself, it is a 12. So 125 over 10. That is what gives us the 12.5. Then we say divided by 100. That is the over 100 is over here, the percent. When it comes to division by what? A number, what do? We change it to multiplication and reciprocate what we have over here. So that it becomes 100, or since this is 100 over 1, it becomes what? A 1 over 100. Easy. Then with that, we are going to get a 125 all over 1,000. 125 over 1,000. We know 125 divides itself once, then divides 1,000 8 times. You see, so all this question was actually requiring of us is to change this to what? 1 over 8, and then multiply it by what? 100. That is the off, and then the 800 over here. So with that, we know 8 divides 8 once, then we just attach the annexing zeros, and that is going to give us what? A D, which is 100. Question 48. 48 simply says, how many factors does 36 have? So if you want the factors of 36, we can easily do that by determining the numbers that multiply each other to give us 36. You know 1 times 36 gives us a 36. So 1 is a factor, 36 is also a factor. We have 2 times 18, which also gives us a 36. Then we have 3 times 12. And then we also have a 4 times 9. Easy. And then finally, we have a 6 times 6. So there's no need repeating the 6. So for the factors, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 factors of 36. Question number 49. It says, which of the following numbers is the prime factorization of what? 315. 315. So we just express 315 as product of prime factors, which we've done so many times, and I do hope you're able to get the answer. So for 315, we know it ends in 5, so we can easily start with 5. So 5 divides 315 63 times. Then for 63, we can also easily work with what? 3. 3 times 21 gives us 63. For 21, we can still work with 3 as well. And 3 times what? 7. So 315 is actually a 3 times 3 times 5 times what? 7, which is 3 squared times 5 times what? 7. 3 squared times 5 times 7, that gives us what? C. And now our last question for this session. It says, when finding the LCM of two numbers, P and Q, using prime factorization, what do you need to do? When we want LCM, we've done that so many times. The LCM, we just multiply all the prime factors present in their numbers using the highest powers of each. Remember, the highest powers. LCM has to do with highest powers. A says multiply P and Q and then divide by 2. That is totally false. Add the prime factors of P. No. Multiply only the prime factors that P and then Q have in common. No, that is the HCF rather. D says multiply all prime factors present in either numbers using the highest power of each. And that is our right answer. I do hope you were able to get a perfect score. This is Hard Beyond Numbers, where we learn maths the easy way. And I do hope this lesson was helpful to you. If there's any issue of concern, if I was either going too fast or too slow, you can always let me know in the comment section. If you want more questions once again on this particular lesson, you can also let me know and I'll do that for you. We have so many tutorial sessions on the homepage. You can also check to be able to enhance your understanding on this topic. If this was your first time on this channel as well and you so do wish, you can choose to subscribe so that anytime I release a video, you'll be notified as well. See you in our next lesson. Bye for now and do stay safe. Bye-bye.